Hi, so today we're doing hyperbola. Very quick. So hyperbola, basically what you need to understand is four things, right? Firstly, the formula of a hyperbola, right? The formula of hyperbola will be given in the form of this: x minus p plus q, right? So this is the form of a hyperbola. A hyperbola has asymptote, okay? Has asymptote, right? What is asymptote? I'm just going to show you just now. So, but there are two types of asymptote. There's an vertical asymptote, vertical asymptote. Well, a vertical asymptote is this part here equal to 0. So it's this part equal to 0. That's a vertical asymptote. So you say x minus p is equal to 0, and then you solve for x, your x is equal to p. This is your vertical asymptote. And you have horizontal asymptote. Okay, a horizontal asymptote is this here. Okay, positive q. So that's your horizontal asymptote. Y is equal to that positive q. Why I'm saying positive q is because you can have an equation where it is negative q. Okay, if it's negative q, then your horizontal asymptote will be negative q. Make sense? Right, and let's just keep it positive. That's first thing. Second thing, there's what you call intercept. So we have x-intercept, right? And x-intercept is when you let y is equal to 0. So you let this thing here equal to 0, right? So meaning you're going to let y equal to 0 and then you solve for x. Then solve for x. That is your x-intercept. Your y-intercept is you let x equal to 0, then you solve for y. So what do you do? With this one, you let x equal to 0, then you solve for y. Okay? So the picture of an asymptote, not an asymptote, rather, of a hyperbola will look like this. Say this is your x-intercept, your x-axis and your y-axis. Now, I said you have a vertical asymptote. A vertical asymptote will be something like this, right? So let's call this line, let's say this point here is P, and the vertical asymptote to be a line passing through P. That's your vertical asymptote. And horizontal asymptote to be this one. So let's say we have this point here called, let me just make it up here. Let's call this point Q. So your horizontal asymptote to be this line here. Okay, and then your x-intercept, x-intercept, x-intercept is when y is equal to 0. It can be here, it can be somewhere there, it can be somewhere there. That's your x-intercept, right? Let's say your x-intercept is somewhere here. And then your y-intercept, let's say your y-intercept is somewhere here. Okay, so if that's your x-intercept, that's your y-intercept, and then you will have your graph will look like that. So how do we draw this? It approaches your y-intercept and your x-intercept, and it doesn't touch your asymptote, right? It passes through your y-intercept and your x-intercept, but it doesn't touch your asymptote. So it approaches asymptote, doesn't touch it. And the other one that you need to write automatically, it's the one that is opposite in this point here. That one, you write it like this. Okay. Or sometimes you might find that you have an x-intercept here, and they told you also have a y-intercept here. And So how do you draw this? It's always like that. It's always in a hyperbola shape, approaching your asymptote, passing through the intercept, in this case which is x-intercept. See, it approaches your asymptote, passes through your y-intercept, and approaches asymptote. Okay, so if you write it this way, don't forget to write this one. If you write it this way, obviously you're gonna get that one. So that's basically a note of a hyperbola. Let me give you a quick question on this study. Okay, so let's go for it. So let's say you're given this. Okay, so that's your answer, that's what you're given, and they ask you to draw a hyperbola here. For first you need to find your vertical asymptote. Vertical asymptote, we said the vertical asymptote is this thing here, equated to 0, right? So vertical asymptote will be x minus 1 equal to 0. So this will give you x equal to 1. So that's your vertical asymptote. A horizontal asymptote. So horizontal asymptote is this thing here, y, which is y is equal to 2. Okay. Thirdly, your x-intercept. X-intercept, we said you let x equal to 0, and so for you let y, sorry, you let y equal to 0. In our case, you let this thing equal to 0. So you're gonna have 0 is equal to -3 x minus 1 plus 2. Okay, so what it did is we let h to be equal to 0, and then you're gonna solve for x. So you're gonna take this, put it on the other side, becoming negative. The sign will change to be negative, so you're gonna have -2 is equal to -3 over x minus 1. And then from here you can cross multiply. Okay, so you're gonna have -2 times x minus 1, -3 can divide by -2 on both sides. So this and this will cancel, so you have x minus 1 is equal to -3 over -2 will be positive 3 over 2. And then take -1, put the other sides becoming positive 1. So you're going to have x equal to 3 over 2 plus 1. So your x will be 5 over 2, which is 2.5. Okay. So now let's try and draw this. Let's try and throw it somewhere here. Okay, so what is your vertical asymptote? X equal to 1. That's your vertical asymptote. X equal to 1. So vertical asymptote is saying somewhere here there's 1. So we throw the vertical asymptote. And horizontal asymptote, y is equal to 2. So that's your horizontal asymptote. Y is equal to 2. Let's say this is 2. So you draw a horizontal asymptote line. Cool. Now what is our x-intercept? Our x-intercept is 2.5. So here we have 2.5. Okay, so one thing we didn't do is y-intercept. So let's try and find y-intercept. Y-intercept, you said let x equal to 0. Okay, so you let x equal to 0. So you're gonna have h. You see, this is h of x. Where there's x, you put 0. Okay, so you have h of 0 is equal to -3 over 0 minus 1 plus 2. Okay, so if you can punch this in your calculator, this whole thing in your calculator, and get your answer, you can just work it out with me. -3 over -1 is 3 plus 2. So your y-intercept is 5. So your y-intercept is 5. Cool. So that looks clear to me. Now you see that your graph will look like this. It approaches the asymptote, passes through the x-intercept, and it approaches the asymptote. See? Approaches the asymptote, passes through the y-intercept, and it approaches the asymptote. Ta-da! This is your y. I don't know why I said that, but this is how you actually draw your hyperbola. Awesome.